All right, ladies and gentlemen. So we've learned about the basic trig functions, okay, which are SO, COT, TOA, but today we're going to get into the other three, okay, which are basically just the reciprocals of these three, okay? So let's jump right in. So we have SO, COT, TOA. What does that stand for? Well, that stands for sine, cosine, and tangent, right? And of course, we're talking about angles, right? So I'll just call them x. So sine of some angle is equal to what? Well, we're talking about a right triangle here. And so if we have a right triangle, right, and let's say x is right there, that's our angle that we're interested in, then this becomes adjacent, this becomes opposite, and this becomes hypotenuse, right? Which is where we get the SOHCAHTOA from, right? And so notice here, the sine would be so opposite over hypotenuse. So we'll just write it that, opposite over hypotenuse. So it's a ratio, it's a fraction. Okay. What about cosine? That would be ka. Ka is adjacent over hypotenuse. Right? Adjacent over hypotenuse. Sine would be opposite over hypotenuse. And then tangent would be toa. Opposite over adjacent. Okay? So those are the three basic trig functions or trig ratios. Okay? So we have so, ka, toa. Now, where do the other three come from? Well, they come from these three here. And they're basically just a reciprocal, and they have three special names, okay? So notice here, we have cosecant, secant, and cotangent. And these are the reciprocals of these, okay? So this is 1, 2, 3. And then in order, we have 4, 5, 6. So these two are reciprocals, these two are reciprocals, and then these two are reciprocals, okay? And then, of course, these are going to be of x. So let me just fix this here. I don't want to write it too close. So here we have cosecant of x, secant of x, and cotangent of x, okay? And so what are they exactly? Well, they're just the reciprocals of these, okay? And so cosecant is just going to be hypotenuse over opposite. Secant is going to be hypotenuse over adjacent, okay? And then cotangent is going to be adjacent over opposite. If we wanted to create a little like phrase, so katoa, that would help us remember this, well, I guess you could come up with CHO, SHA, and then CAO. Cho, sha, kao. Now, in reality, we're never going to have to remember something like this, okay? All you really need to remember is so katoa. And the reason we use these is just so that we become familiar with them in case you move on to calculus. You'll be using these when you work with derivatives, okay? Which is a term that you'll learn about in calculus if you go that direction, okay? So, in reality, all you need to remember is so katoa, right? These three, and then the reciprocals, you have them here already. It's going to be HO, HA, and AO. But what about the first letters? Well, just remember here, the reciprocal of sine starts with a C. Let me just draw a little arrow here. Okay? And the reciprocal of cosine here starts with an S. And then tangent and cotangent, that's the easy one to remember because they both have the word tangent in them, okay? So, cosecant, secant, and cotangent. Notice it's C, S, C, okay? I always like to write it in this order, so, katoa, and then notice here, if you just write the first one here, CSC, down the line like this, down in the list, CSC, then you'll always have your reciprocals. Cosine, the reciprocal of sine is cosecant, the reciprocal of cosine is secant, and the reciprocal of tangent is cotangent. You see that? So just, if this starts with S, then your reciprocal starts with C, and then just write CSC going down like that, and then you could just write all the other ones across, CSC, SEC, and COT, okay? So notice here, again, as long as I find these three up here, then I can automatically find all these three. So now let's put it into practice. Check this out. It says here, find all 6 trig ratios using the triangle below. So let's start with SOHCAHTOA. SOHCAHTOA. Okay? Now, I did not put an angle here, so let me just call this x right here. Okay? So, let's go ahead and begin here. So, if this is the angle I'm interested in, then this is adjacent, opposite, and hypotenuse. So, if this is the angle I'm interested in, and on the test, it may be written like this, A, B, C, right? And so they'll tell you, okay, find the 6 trig ratios of angle B, for angle B. Okay, so in this case, it would be like if they're asking angle B right here. Okay, and so now that we've identified the sides of the triangle, this is adjacent, opposite, because remember, it depends on which angle they want us to use. If they use A, then this is adjacent and that's opposite. If this is the one they want us to use, then this is adjacent and that's opposite. So it really depends, okay? And the hypotenuse is always the longest side of the right triangle. So, let's do sine. Sine of x equals opposite over hypotenuse. That would be 4 over 5. You want to find these 3 first, okay, before we do the reciprocals. And then cosine of x is going to be adjacent over hypotenuse. So that's 3 over 5. Okay, and then tangent of x is going to be TOA, opposite over adjacent. So 4 over 3. Okay, and so now I can do my reciprocals, right? So remember, if that starts with an S, we start here. C, S, C. Just do that. And so this is going to be cosecant, secant, and cotangent. Okay, so of the same angles there. Okay, so the reciprocal of cosecant is sine, so that's 4 over 5, so we just write 5 over 4. Okay, and I could just go down the list. It's going to be 5 over 3, and then 3 over 4. That's it. Okay? Very simple. Now, I wanted to show you guys something really quickly. These are right triangles. That means that Pythagorean theorem works. Check it out. 3 squared plus 4 squared. 3 squared plus 4 squared equals 25, right? And so if I take the square root of that, square root of 25, I'll just put it like that, equals 5. So notice a squared plus b squared equals c squared. Okay? Let's try this one here. This one, I'm going to label it A, B, C. And let's use A right here. So I'll call A the X here. Okay, so we're going to use A to find all 6 trig functions. Okay, trig ratios. And so let's start with SOHCAHTOA. We always want to start with that. Okay, and so sine of X, cosine of X, tangent of X. Okay, so let's see here. X here is going to be, first we have to label this, right? So remember, the right angle here is always across from the hypotenuse. So that's the hypotenuse. And so this is the adjacent, and this is the opposite. Okay? So sine, we have opposite over hypotenuse. So 5 over 13. Okay? Cosine is going to be adjacent over hypotenuse. So 12 over 13. And then tangent is TOA, 5 over 12. Okay? What about the reciprocals? So the reciprocals, again, if that starts with an S, we start with a C. C, S, C. Just write it like that. And so it's going to be, messed up there. This should be cosecant. So this will be CSC of X, secant of X, and then cotangent of X. So the reciprocals here are just going to be going down the list here, okay? So remember, as long as you write these in the right order, right? If that's sine, then you want this one to start with the reciprocal of it, which starts with a C, cosecant, secant, and cotangent. So let's go ahead and write. This is going to be 13 over 5, 13 over 12, and 12 over 5. Now on the test, they may be written out of order, so you need to make sure that on paper, you can write them in order, and then you can just put them in the right box on the test, okay? That's it for this one. Pretty simple, huh? Okay, now take a look at this one. It has a square root in the problem. If I go ahead and do the Pythagorean theorem here, notice here, the square root of 13 squared plus 6 squared right? So it's a squared plus b squared equals c squared, right? Well, notice, if I square 7, do I get 49? Yes, I do. So this is actually a correct right triangle. Okay, so again, let's start with SOHCAHTOA. Okay, and so we do sine of x, we'll put the x right now, cosine of x, and tangent of x, right? Okay, so which angle do I want to use here? Let's just say I want to use this angle down here, okay? And so that angle is the one I want to use, and that means this is the adjacent, this is the opposite, and that's the hypotenuse. Remember, the hypotenuse is always the longest side across from the 90-degree angles, okay? It's always going to be across from the 90, and it's always going to be the longest side of a right triangle. Okay, here we go. So opposite over hypotenuse, so 6 over 7. Okay, cosine is going to be adjacent over hypotenuse, so it's going to be square root of 13 over 7. And then tangent is going to be TOA, which is opposite over adjacent, so it's going to be 6 over square root of 13. Now, listen closely here. This here technically is considered not fully simplified, okay? If we wanted to simplify a fraction with a square root in the denominator, we would have to rationalize it, okay? And to rationalize it, the simplest way to rationalize is just to multiply both sides, rather the numerator and the denominator, by the radical here. Okay, so we could just multiply by radical 13 there, okay? And so then this would be like multiplying by a form of 1. Notice it's a whole fraction, so it's going to give me an equivalent fraction. So this would become 6 radical 13 over, oops, I messed up there. When I multiply square root of 13 times square root of 13, that's like squaring this, right? Which means I get 13. Why? Because look, the square root of 13 times the square root of 13 is 13. Why? Well, notice, what's 13 times 13? 13 times 13 is 169. Let me do this right here. 13 squared is 169. Okay, so now if I take the square root of that, square root of 169, what do I get? I get 13, okay? So this would be the simplified answer, and this would be unsimplified answer, okay? Now, on the test, you are allowed to leave it like this, but just know that in most cases, you would need to rationalize the denominator, which means to get rid of the radical in the denominator, okay? So let's go ahead and just do the reciprocals now. Let's just use this here. Let's just use here this here, and then just write the reciprocals. Okay, so this would be, remember, starts with an S, so this would be start with C, S, C. And so this would be CSC again, like this. Cosine of x, cosecant of x, and then secant of x, and then cotangent of x. Okay? And then it's just a reciprocal, 7 over 6, 7 over square root of 13. We would have to rationalize this again. And then this one here, square root of 13 over 6. Okay? So let's rationalize this just to get a little practice here. So we would have to multiply this by square root of 13 over square root of 13, which would be 7 square root of 13 over 13. Okay? That would be the rationalized answer. Okay? And everything else is fine. Okay? All right, so now I want you guys to try this one. Notice the angle that I want you to use is up here. Okay, so copy the problem down, pause the video, and then find all 6 trig ratios. Okay, now pause it because I'm about to solve it for you. So don't just watch me do it. I want you guys to honestly try it on your own, because this will be a question on the test. Okay, a problem like this you will see on it. And so let's go ahead and do it here. So we have SOHCAHTOA. If you didn't pause the video, pause it. Make sure you do it yourself, okay? So then we have sine of x, cosine of x, tangent of x, right? SOHCAHTOA, okay? And then the reciprocals, right? C, S, C. Okay, so there's all 6 of them right there. So let's go ahead and label our triangle here. So this will be adjacent, because they want me to use that one there. Opposite and hypotenuse. Okay, and so here we have sine is so opposite over hypotenuse, so it's going to be 7 over 10. Cosine is going to be adjacent, square root of 51 over 10. Okay, and then we have TOA, opposite over adjacent, so we have 7 over square root of 51. Okay, I'll leave it like that for now. And so let's do the reciprocals here. Since I wrote them in order, I could just go down the list like this and do the reciprocals. 10 over 7. 10 over square root of 51. And square root of 51 over 7. Okay? That's it. Now, let's go down to the ones that have the denominator, that have a square root in the denominator. Let's go ahead and rationalize that. So this would be multiplied by square root of 51 over square root of 51. Same thing over here. Square root of 51 over square root of 51. Okay? So this will be 7 square root of 51 over 51. And this would be 10 square root of 51 over 51. Okay? Now, students ask me, well, we need to rationalize it. You know what? Both will work on the test. If you leave it like this, you can get the right answer. If you leave it like that, I'll be like, oh, I'll be impressed. I'll be like, wow, this guy really knows how to do math. Okay? So, both of those are okay. And that's it.